Welcome to lesson 3.5 and 3.6. Today we're going to briefly talk about the reason we solve chemistry problems the way we do, and then we're going to move on into percent composition. Conceptual problem solving is what we actually do in chemistry that works the best. Most students suffer because they want to do a problem the same way every time. And so a lot of students will try to memorize, and what that does is that they can do one type of problem, and then when they get another type of problem, it requires them to figure out a different way to do that problem. What conceptual problem solving does is it helps students learn a few things and then manipulate to solve, and then look at answers and say, does that make sense? So the steps we look at are: where are we going, how do we get there, and then does our answer make sense? Okay, so now let's look at percent composition of compounds. Percent composition is basically just figuring out how many parts of the whole and putting that in percent. So mass percent is the mass of an element in 1 mole of a compound divided by the mass of 1 mole of the compound times 100. So in carbone, that's a substance that occurs in two forms having different arrangements, but it does have the same molecular formula. One type gives caraway seeds their characteristic smell, and the other type is responsible for the smell of peppermint oil. Compute the mass percent of each element in carbone. So where are we going? We're trying to figure out the mass percent. What do we know? We know the molecular formula. We also actually know the atomic masses from the periodic table and the molar masses. So how do we get there? We determine the mass of each element in 1 mole. So again, just kind of like we did when we were calculating molar mass, just look at these things separately and calculate each of these separately and just kind of set it aside. Now to figure out the molar mass, what you're going to do is you're going to add all those together. Okay, so the mass percent of each element is going to be the fraction of the total mass. So for example, carbon, the carbon in carbone is 120.1 grams. We divide it by the molar mass times 100, and about almost 80% of carbone is carbon. Please note on this that in the percents you'll want to go out to 2 decimal places. We do the same thing. This is the part that was hydrogen. This is the molar mass. This was the part that was oxygen. That's the molar mass. Those individual percents, including the carbon one, should add up to 100%. And that's why I like to go out to 2 decimal places. This one went out to 3, but I normally go out to 2. Here's a couple more problems. This is acrylic acid and then methyl acrylate. So kind of work through those and pause the video because I'm going to show the answers here. Work through those and see what you come up with for mass percents. And then this last slide in this presentation looks very similar to the last slide on lesson 3.4, but it does say highest percent of oxygen by mass, and we could run through these and do each of these separately, but if you recall, which one had the greatest number of oxygen atoms per 100 gram sample, it's the same logic, and so your answer here is going to be water. Your answer here is going to be A on this one. That concludes lesson 3, 5, and 6. Next time we're going to use these percent compositions and look at molar masses. And, look at molar masses and empirical formulas.